Dear moderator, panelists, ladies and gentlemen, my name is Sumaya Al-Hadrami, and I welcome you all on behalf of Dr. Mohammed Al-Ali, Director General of Trans Research and Advisory. First of all, I want to take this opportunity to thank you all for joining us at this exceptional event. We are incredibly excited to be hosting an event on space at a time of unprecedented global crisis. We are excited because this event promises to break new grounds in our understanding of space, which could be the way to more secure and prosperous Earth. Tonight, we are not just looking at the impact of space in redesigning humanity's future, we are also looking at it as a new frontier of geopolitics, innovation, and discovery. The elite panel that has gathered tonight will shed light on critical areas such as space's strategic dynamics and its policy implications. We will also hear more about the vision, goals, and prospects of space missions worldwide and understand the militarization of space and its consequences of international security. The space economy's growth potential, innovative global strategies, and best practices are some of the other areas that we will tackle tonight, besides the challenges related to human settlement, the commercial and industrial aspect of space. On that note, it is time to dive deep on a subject that is bound to keep us excited for generations. And now, I give the floor to our moderator of the night, Mr. Marcus. Mr. Marcus, the floor is yours.
Thank you very much, Sumaya. It's a pleasure to be here, and I would like to welcome all of you to the E-Symposium on the impact of space in redesigning the humanity's future. From very early ages, the space has had a mesmerizing effect on most people and has attracted numerous gifted minds, like Copernicus, Galileo, von Braun, Hubble, to mention just a few. And the developments in the area have been amazing. I was privileged to join this industry some 40 years ago, and I have witnessed major developments in areas like Earth observation, communications, lunar and planetary missions, and navigation systems as well, which we see on the day-to-day. I also saw leaps in technologies in areas like power subsystem, optics, propulsion, launch systems. But I believe that when it comes to impact of space in redesigning humanity's future, what we are just beginning to scratch the surface. I think a lot more will happen over the next years, and I think the impact will be very big. We are seeing major developments in areas like plans for new constellations, missions to the moon, to Mars, asteroid mining for the more eccentric ones. And the years ahead will be exciting. And our speakers will help us to get a glimpse of what is to come. On organizational matters, we have a tight schedule, so I would ask all of you to try to keep within your allocated times. I'll do a brief introduction for each of the speakers, and I apologize in advance for any mispronunciations of names and omissions, as we have people from many different places. On this note, I would like to introduce Dr. Simonetta Di Pippo, our keynote speaker. She's the director of the United Nations Office for Outer Space Affairs, based in Austria. She's an academician of the IAA and a member of the WF Global Future Council on Space Technology. Dr. Simonetta co-founded the Women in Aerospace in Europe in 2009, and in 2017 she became a UN International Gender Champion. I also think it's worth noting that in 2008, the IAU named asteroid 21887 Di Pippo in honor of her contribution to the space activities. Dr. Simonetta, please.
So thank you very much for the introduction, and let me tell you that you pronounced my name perfectly. So very good. So distinguished guests, fellow speakers, really grateful for the opportunity to address this event, which is, by the way, is a wonderful title, if I may say so. So also my best compliments to the organizers and to Trends. Space is indeed all around us, and it's not just metaphorically. Our activities in this unique environment have reshaped human society into a modern, globalized, and connected civilization, and they've also changed our perspective of the Earth. And increasingly, we have also come to realize that near-Earth space is a finite resource that we need to protect and preserve in the interest of all humanity. So from a bipolar arena with a limited number of actors dominated the field in the past, the sector has evolved into a multipolar domain. The diversity that has developed, especially in the last 10 to 20 years, is astonishing. And the commercial side of the industry now by far outstrips the value of state-led efforts. And it also joined by academia, civil society, and international organizations all becoming increasingly involved. As a result, space economy is breaking records every year, and so is the number of new spacecrafts. Just recently, we closed an unprecedented year, 2020, with over 1,260 satellites launched, more than double the previous record. These are all fantastic news. Exciting times are really ahead of us. But let's remain vigilant. Plurality also means complexity. Our conduct today and tomorrow has an impact on the future generations of space explorers and also future generations on Earth. The behavior in this global common, therefore, must be in line with the highest standards of transparency and responsibility. And we must, more than ever, embrace international cooperation. It is therefore very exciting to see that this time, when the international space community turns its attention back to the moon, to Mars and beyond, it is not a race, but a common effort to push the boundaries of what we can do as a species. Through the lens of the United Nations, we celebrate this approach. It is great to see that the values of cooperation and peace, which are at the foundation of the UN, remain the guiding force behind space exploration efforts for the years to come. What we have also advocated for throughout the decades of the UN existence is equality. We still have a long way to go in many sectors, including space. We must intensify the focus also on inclusiveness. The workforce in the aerospace sector remains significantly imbalanced, with only 20% of them being women. As we strive to set off towards a new exciting chapter in space exploration and utilization, we, the Office for Outer Space Affairs, we envision a sector in which everyone has a role to play with no bias, discrimination, or discouragement. It is time we put the perspectives of young women and girls on par with those of men in STEM in general and in space in particular. I'm grateful that many efforts are ongoing in this regard. At the Office for Outer Space Affairs, we are also contributing in this field. We are running the Space for Women project, providing tailored advice, expertise, knowledge, and data to improve access to and use of space, to motivate, educate, and train women and girls internationally. This is not only the right thing to do, it also means success. More minds mean more ideas. More ideas mean innovation. And more perspectives mean that innovation can be utilized in a manner that truly benefits everyone. This is the roadmap we consider as the only means forward at the United Nations, a sector with concrete, agreed, and mutually beneficial rules leading the way, and a sector which celebrates diversity and inclusiveness. If we adopt this approach, going forward as one space community, we can and we will succeed in exploring space in a manner that is both progressive and successful, and also sustainable. That's the road to success, and the road that we at the Office for Outer Space Affairs, with great support of many partners all over the world, have been building since the beginning of the space age. So with this, I'm really happy to be here again, to be able to really deliver this keynote, because I do wish you all a productive and successful event. And let's do it again. It's absolutely outstanding what you're trying to do. And I would like again to thank all the other speakers to devote their time to this important event. Thank you very much also for listening.
Thank you very much, Dr. Simonetta, for the very valuable points in the keynote speech. I now would like to introduce Dr. Namurata Goswani. who will talk about the strategic dynamics of space, geopolitical dimensions, and policy implications. Dr. Goswami is an independent scholar on space policy, great power politics, and ethnic conflicts. She has been a subject matter expert in international affairs with the Futures Laboratory in Alabama, and in 2016 to 17, she won the Minerva Grant Award by the Office of the U.S. Secretary of Defense to study great power competition in the gray zone of outer space. So thank you very much for being with us, Dr. Goswami, and the floor is yours.
Thank you, Marcus, and it's such a pleasure to be here among such esteemed panelists. So let me share my screen quickly so I can. So today I'm going to speak a bit about the strategic dimensions of space, looking at geopolitical and dimensions as well, and to include the policy implications. I think this is a great topic to start with because in terms of what do you mean when you say strategic dynamics of space? So by strategic dimensions and dynamics, what is meant is that it talks about the distribution of power and relative capacity. So when we look at space, space is not something that is compartmentalized in terms of how nations perceive their role. It is also included within their political culture. And by political culture, I mean that kind of culture that just doesn't just tell you what kind of politics will influence space, but it also tells you the limits of attention that might affect your judgment. Now, from political culture flows strategic culture, and I define strategic culture as the elite's conception of threats and opportunities from a particular environment. And so in the domain of space, especially from the strategic perspective, grand strategy plays a very key role. And grand strategy could include the survival of a nation, space as a support function to their military, but it also includes space as a conception of regional dynamics, which means how does it add to a nation's power projection capability regionally, and also to become a global actor. Now, what is interesting in the last 20 years, as Dr. Pipa mentioned, is that the concept of space is changing. So it's not just about geopolitics, it's become a lot about astropolitics, which was formulated by my very good friend, Dr. Everett Dolman, who pointed out that nations are starting to look at the impact of space from their geopolitical conceptualization. The other important thing that has happened in the last 20 years is that unlike the Cold War, where space was a lot about who gets somewhere first, and it was a lot about missions. So you go somewhere first, you showcase your capability, and then you come back. It's become more about activities. So nations are now talking about permanent presence, lunar mining, space-based solar power. And so as you can see, the conception of space has changed. The other important thing that has come to bear, and which has good bearing for the E-Symposium that we are in, is that space is also being viewed from a very long-term perspective. So nations have plans 100 years in advance as to what they are going to do in space, including the United Arab Emirates. The important factor, again, is that the rise of the private sector. In the Cold War, we did not have the influence, for example, of a SpaceX. SpaceX now has reusability. It is the only company that has launched 143 satellites on a single rocket, beating the Indian record of 104 satellites. And then it also is working on a very heavy lift, reusable rocket capability, which is Starship. Now, the growing importance of space for civil and military activity is, it cannot be emphasized enough. It's becoming a very critical component of how societies, including civil society, actually organizes themselves. The other discourse which has happened in the last few months is that the utilization of space resources, at least in the United States and China, are becoming a very critical component of their grand strategy and policy making. And then, of course, in terms of capacity, most nations are investing in launch infrastructure because of the important fact that if you want to go to space by a cheap means, you will have to bring down the cost of launch by investing in reusability. Now, in that context, if you look at US space strategy and geopolitics, you would see that in the last 8 years, there has been a conversation about using space from the commercial perspective, not just for state power. So you had the Commercial Space Launch Competitive Act, which was signed by the Obama administration. You had several legislations coming out of the Trump administration, including the establishment of a Space Force in 2019. You also have the Artemis Accord that NASA has put out, the preamble of it, which talks about utilization of lunar resources, safety zones, in collaboration with other countries. So it's a very exciting kind of context that we are in today. Now, if you look at China's grand strategy in space, which is another important actor in the strategic dimension that I'm talking about, for China, focusing on maintaining access and use, space command and control is one of their most critical policy goals. The second important goal is that they want to become an important actor in terms of writing the rules of space commerce in the future that we are looking at by 2070, 2075. The other important component, if you look at China's grand strategy, is that space is a very critical component of their national development strategy, including their 2021 National Defense Law, which came into effect in January of this year. China equates the spirit of aerospace to the spirit of the Long March, which inspired China to become the People's Republic of China in 1949. Now, some of China's civilian and military space capabilities are, of course, their heavy lift Long March 5. They're developing a Long March 9, which is going to become effective by 2030. They're also investing in reusability. And that is, again, a very critical component of China's investment in terms of bringing down costs, especially given their first grand strategy, which is maintaining access and control of space. China has several launch capabilities. We have the Jiuquan Satellite Center, but you also have the Wangchang Space Launch Center, which has some advantages in Hainan because you can transport your rockets by sea. And they also have a sea launch capability. So in terms of the context I'm placing, it's not just about policy, it's also about developing capability, especially launch capability. Now, if you look at India's future space timelines, if you can see, they are also looking to the year 2025. So basically to develop satellite-based communication, further space science, but also heavy lift launcher capability and reusability. So it's critical from the perspective of the great powers I'm talking about that they are focusing a lot on developing reusable launch. Now, some of India's space capacity, of course, we all know, includes the Polar Satellite Launch Vehicle, GSLV. India is capable of going to Mars and orbit around it, and India has been investing in lunar missions. But what has changed in the last 3 years is that India is also starting to invest heavily in military space capacity, including an anti-satellite weapon that they launched in 2019. India also has a very growing new space sector. So you can see that all the three great powers that I'm talking about, the United States, India, and China, are starting to invest in their private space sector in the last 3-4 years, realizing the global impact of such capability. Now, India has 2 launch ports, basically in the south of India. And so launch capacity is, again, a critical component of the thinking of these great powers. Russia is a very serious space power with its own launch capabilities. But what is interesting, again, from a future perspective is that Russia is also starting to articulate going back to the moon for permanent presence capability. So it's no more about just supporting the military, civilian space capability, showing off capability like in the Cold War, but it's actually about thinking about becoming a country that is able to sustain itself on the lunar surface by the year 2040. And of course, Russia and China have good cooperation, including on their lunar missions. Now, before I end, I would say that some of the actors that are making a great dent into the constitution of norms and capability in the world, which the United Nations Office on Outer Space Affairs talks about, is that we don't have the Cold War repeating again. We have new actors that are actually going to influence space in a deep level. Japan is a very serious spacefaring nation, but what is interesting is that in the last few years, Japan is also starting to talk about lunar missions, developing its private space sector, including the importance of space situational awareness, and in collaboration with India and the US, Japan wants to actually establish capability to go to the moon. So you can see that the world of space is complex today. And it's getting further complex because you have countries like Indonesia, which we don't talk about much, especially in the US. I don't hear many conversations. But Indonesia is also starting to argue that because of its favorable location near the equator, it wants to become a serious space launch country, including officially inviting SpaceX to invest in their spaceport last year by the president. So you can see that Indonesia is starting to realize the return of investment from space, which is going to be in the trillions of dollars, is a very strategic asset to be invested in. Now, the country that I think would be interesting to this audience is UAE. UAE actually has one of the most future space goals I have seen. By 2117, the UAE aspires to develop a city on Mars. We know that the UAE Hope probe, which is their Mars mission, is going to be the first mission this year that's going to enter the Martian orbit by February 9th, followed by China and then by the US. So for UAE, it's very critical that they become a serious hub for space activities in the next 20, 30 years, and they have already signed the Artemis Accord. Now, Saudi Arabia, again, another country in terms of looking at the strategic dimensions of space, including investment in space launch infrastructure, international partnerships. And we all know that Saudi Arabia actually promised to invest in Virgin Galactic, about $1 billion. But of course, that did not work out because of concerns in regard to their journalists. Now, in my last 3 slides, I'll tell you that it is really critical for us to understand that the space order, or the international space order that we are talking about today, is no more just dictated by the great powers like China, India, US, and Russia. It's actually the new actors which are going to make a huge dent by the next 20, 30 years. Australia is one of such actors, and then New Zealand, which actually has one of the largest launch capability, including Rocket Lab, which has launched an equal number of rockets to India, Japan, and Europe in 2019. So what are the policy implications of all this complexity? So we have Africa, for example, which has come into the strategic dimension. Africa has Africa Space Agency that they're establishing in Egypt. They have an African agenda that wants to look at space from the space economy perspective. We have Luxembourg, which has come up with its space mining legislation. And because of that, the policy implications are critical. So for example, one of the scenarios that I study in terms of conflict is that given the fact that countries like the US, China, Russia, and India all want to go to the moon, China and the US have very clear space utilization goals, including the establishment of a lunar research base by 2036 for China. Is that going to lead to some kind of conflict, given the fact that we do not have very clear articulated space law that deals with that kind of future? And I think I would end by saying that in the context that I have offered you in terms of the diversification of space power, space economy, and the investment in space commerce, the laws of today are basically based on the Cold War, when we had the 1967 Outer Space Treaty that actually do not allow national appropriation of sovereignty or the placement of weapons of mass destruction, but does not account for private space actors, including the goals of some of the countries that I've talked about for utilization of space resources for their own economic development. So we will have to basically be very clear in terms of the next 20, 30 years, how are we going to constitute these norms and who decides who owns what in space. So I think I'll end there and thank you for your attention.
Thank you very much, Dr. Goswani. I think a very good summary, especially when you look at the launch capabilities. I think was very good put together. Thank you. Now, I would like to introduce Dr. Farouk, who will be talking on the upcoming significant space missions and beyond, visions, goals, and the future prospects. Dr. Farouk has a long history in the space industry, and in 1967-72, he participated in the Apollo program as a Secretary of Lunar Landing Site Selection and Chair of Astronaut Training in Visual Observations and Photography. In 1973-82, he established and directed the Center for Earth and Planetary Studies at the Smithsonian Institution in Washington, D.C. So certainly a pioneer who, I mean, I had the pleasure to meet a couple of times in Abu Dhabi. Dr. Farouk, the floor is yours. I heard Dr. Farouk was having some internet problems, so we can give him a 1 minute. And Sumaya, I think we'll then proceed to Mr. Jean-Jacques Tortora. If Dr. Farouk managed to join us, we certainly get back to his presentation. Mr. Tortora will talk about the growth and potential of the space economy, global strategies and best practices. Mr. Tortora serves as the director of the European Space Policy Institute, and he was also the Secretary General of SD Eurospace, the European Space Industry Trade Association, and was involved in launch service with Arianespace, looking at risk mitigation, cost reduction plan for the Ariane 4 operational life. Please, Mr. Tortora.
Thank you very much, Marcus, for this nice introduction, and thank you to the organizers for having me today. It's a great pleasure and a great honor to sit among such a prestigious panel. Actually, we'll talk about the space economy, global strategy, and best practices. This is a vast topic, and it is clear that the space activities worldwide and the space economy have been very stable over decades. Since the inception of the space era in the 60s and until, I would say, the end of the 90s. At that time, only a handful of space powers and of spacefaring nations were having access to space. We had a limited number of industrial players having the proper capabilities, a very limited number and share of privately led initiatives, and all spread into over a handful of applications, and everybody thought that this would last forever. However, over the past decade, 3 new space infrastructure companies have raised an impressive number of $17 billion in cumulative equity investment. I will not repeat what the previous speakers said before me, but this trend is also to be confirmed in 2020 now that we start having the final assessment, I would say, of what happened in 2020. And despite the sanitary crisis, this trend has been confirmed, and we might even see a major spike in the space private investments last year. So these players have introduced 2 radically new and in particular reusable heavy launcher families. They have begun the deployment of 2 and maybe soon 3 very large-scale satellite communications infrastructure. And I would say that on top of that, an additional $7 billion was raised by a very diverse group of something like 900 startups, exploring a variety of emerging business models, and mostly focusing on development, deployment, and operations of small, micro, and nano space systems, both including both satellites and small launchers. So this, of course, raises a lot of hopes and expectations, but actually only a few tenths of them have managed to raise more than 100 million each, and none has yet demonstrated a viable business case. Now that this new generation of entrepreneurs have envisioned space as the new frontier, and they believed in the great untapped potential of space capabilities to further develop, And especially their reasoning was based on the fact that we heavily rely on space systems, on space-based services in our everyday life, and that space is actually more than a commodity. And all of this put together has shaken the foundations of the sector worldwide, which is something I guess which is quite welcome, and I would like to really salute their outstanding achievements in orbit. And I will join the previous panelists on this. But a few things that I would like to add is that, as I said, now very few have demonstrated a viable business case, and the fact is that space economy is really a lot about what's going on the ground. Actually, the growth of the space economy is sustained by the demand, and at the moment, most of the attention, most of the focus has been on the offer side. And definitely, once again, I would like to salute the extraordinary achievements that have been reported lately. But on the demand side, at the moment, I still do not see much happening. And the fact is that we are now in a highly and fierce competitive domain or era. And of course, companies are competing with each others, but I would like to remind that the fiercer competitor of space systems are the ground capabilities. And actually, every time something can be done from the ground wins. And this is where I think that we still need to demonstrate the dedicated and specific advantages of the space-based solutions that are currently put forward or that are under development. And from this standpoint, I would like also to remind that so far, and as far as the development of the business related to space applications is concerned, all the predictions that we used to make in the past have always been consistently wrong. Actually, everybody predicted that space imagery, Earth observation, commercial market would boom, and this boom actually never happened. Nobody really anticipated the now downturn in the space telecoms. Iridium and Globalstar, two major successful constellations still in operation, they have, I would say, found and managed to become profitable and found applications in areas which were not initially foreseen in their design. So all of this reminds us that we should be very humble when it comes to anticipating what might happen even in the short term. Actually, what we see at work at the moment is really, I would say, a breakthrough, and we are now coming to a new trend. The historical trend in the development of space systems has relentlessly been to improve the performance of the space systems and the space capabilities, improve the bandwidth, improve the resolution of Earth imagery, etc., etc. Mostly for institutional customers. Now, the recent trend and what is at work at the moment within the new space is to seek mass markets for commercial applications, not to seek ever increasing level of performance, but really breaking the barrier of costs. And hence the endless quest for increased competitiveness. We tried in the past to break the barrier of costs, and we believe that this would come through breakthrough concepts, breakthrough technologies. And actually, this is not what is taking place at the moment. What is taking place is really radical optimization of mostly the production part of the space system. And this is actually a game changer, a major game changer. And this definitely has been the key to successfully significantly reduce the cost of access to space, reduce the cost of operations of space systems. Now, the question regarding the development of the space economy is to see whether space markets are elastic. What I mean by that is that, of course, if we, for instance, if we reduce the cost of the space system by 20%, does it result in an increase of the volume of the business by 20%? This would be the case in an ideal world, and I'm afraid that this might not be exactly what will happen in the future. Once again, I will be very cautious on that, but I would like to remain that this growth that we see that at work at the moment, it's still at the moment sustained by intensive capitalistic investments and not yet by the development of the business. Another fact now to address the best practices in the sector, and I will join what once again the previous speakers said before me, is that we also have to face some realities. Actually, space is and all space systems and space-based services, they all exploit space resources, and actually space resources are not infinite, they are limited. Would it be the orbital slots? Would it be the frequencies? Would it be the orbits, or I mean clean orbits and practicable orbits? And actually we are facing and I would say much faster than what we could have expected, the limits of the useful space. Of course, space physically is unlimited, is infinite, but the useful space is not infinite. And this is where we would need to foster some kind of approach to regulation. Of course, I don't like the word regulation, which is always or most often interpreted as something which would hamper the development of the business, but we should see and see it as an enabler to allow us to jointly and safely operate into space. So, of course, what we need there is to agree on a number of agreements, a number of things. So definitely nobody wants binding agreements. So the way forward is probably to investigate what kind of non-binding agreements we might find. We need behavioral changes also to promote the, I would say, sustainable and respectful use of space resources, and what the work which has been done by the United Nations and by Simonetta, who were before me in particular, through the elaboration of the guidelines, is certainly a major contributor to that. So this is what I wanted to say in a few minutes. I think I exhausted the time slot that was awarded, and I look forward to questions and made a discussion with all of you.
Thank you very much, Jean-Jacques. I think your points you made are very good, and we can address more of these when you have the discussion session at the end. I totally share your views on the importance of making sure we have a commercially sustainable approach. Otherwise, it would be very difficult. I would like to go back to Dr. Farouk. Are you with us now, Dr. Farouk?
Yes, now. Thank you very much. I'm sorry to be late just a few minutes.
I had introduced you before, but I'm not going to repeat everything. Just say you're one of the pioneers and you have worked as far back as in the Apollo program. And it's a pleasure to have you with us.
Thank you very much. I just wanted to say that the coming year is going to be the year of planetary science. There are all kinds of missions and all kinds of programs that we're looking forward to learning all kinds of things about planetary systems, first around the solar system and then outside. First, around the solar system, we're going to emphasize the great deal information about Mars. 3 different countries have missions to Mars this coming year, or this year where we're in. First, in early February, we have the United States of America and the China and the United Arab Emirates having missions directed towards Mars. The mission of the United States of America will have a lander to the surface of Mars to describe all kinds of things on the surface, and as well as it will have a helicopter for the first time to roam around Mars to see evidence of different geological things around the surface of Mars. And Mars is very important to us in general because it is very similar to the deserts of the Earth. And the deserts of the Earth show us that there had been quite a bit of rain and water and so on in the past, and then the water dried up and the wind took over, and all we see are the results of wind erosion and wind deposition of material. And that is exactly what's happening on Mars. And we believe that in addition to the fact that we have these wind features on Mars, we will have a lot of material from the past, from indication of the past, including ice beneath the surface. Because as in the case of the Earth, there was quite a bit of water on the surface of Mars, and we have seen all kinds of ancient rivers or the river channels on Mars. So there was water, and there was running water, and there was water deposits on the surface, and therefore there must have been some ice bodies beneath the surface and therefore there would be a potential for life, so to speak. So we have this trio with the American mission, and then we have the first time for China to go to Mars, to land on the surface. And then with the first time, we have a mission by the United Arab Emirates called Amal that will go into the atmosphere of Mars, and particularly the upper atmosphere, so that we can be able to visualize what is happening in the upper atmosphere, because whatever in the upper atmosphere affects the lower atmosphere. The atmosphere of Mars is kind of thin as opposed to the atmosphere of the Earth, but there are winds and there are all kinds of motion of material in the atmosphere. And we have had actually once in Maryland 9 in the 70s a wind storm that picked up particulate matter that covered the whole surface, and we could not see a thing on the surface of Mars for 3 months. So there was a planet-wide dust storm on the surface of Mars. So there is quite a bit of dust that moved on the atmosphere, particularly in the upper atmosphere. And the mission Amal will give us some indications of what is happening in the upper atmosphere of Mars, where the wind moves, and the relationship between the upper atmosphere and the lower atmosphere. And in addition to these two important things, as far as the planetary missions are concerned, we have an opportunity to see beyond the Earth and the solar system, and have the James Webb telescope to look for planetary bodies elsewhere in our galaxy. So there will be a whole bunch of new information coming from space relative to planetary bodies, planetary systems, and planetary activities on the surface of these and within the solar system and beyond throughout the year we're in. So will be a year of planetary science in addition to all other things. Thank you.
Thank you very much, Dr. Farouk. Very interesting points. I think, again, we can try to discuss a bit of that at the end of the session. Thank you again.
Thank you.
Now, I would like to introduce Dr. Henry Hertzfeld. He will be talking about the growth and potential of space economy, global strategies, and best practices. Dr. Henry is also an adjunct professor of law at the George Washington University, and an expert in the legal, economic, and policy issues of space and advanced technological development. Dr. Hertzfeld has served as a senior economist and policy analyst at NASA, and is a consultant to US and international organizations. Please, Dr. Hertzfeld, the floor is yours.
Thank you, Marcus. Hard act to follow, and We're back to the economy, back to terrestrial things here now for a few minutes. And I want to, of course, thank Jean-Jacques for his excellent summary of the space economy. I fully agree with what he said, and in fact, will be echoing some of the same thoughts. We did work independently, by the way. First of all, this symposium is oriented toward predictions, and I think we, particularly when we're trying to predict the economy, we're always wrong. It's a dangerous game. But if we do predict, it'd be great to be able to revise those predictions and do them frequently. Economists have trouble really even projecting a month out or a quarter out, let alone 50 years. And economists also use a lot of assumptions. And we should be aware of them, but of course, nobody pays much attention to them when quoting various economists. So with that being said, let's try to look at a little bit of the perspective of how we've looked at the space economics going back to the 1960s and 1970s. And very briefly, we were looking at returns to government R&D investments, plus the jobs and income created by spending mostly government funds. All of these were significant. We also talked about spin-off technologies, which are important, will be important, but are a small contribution to the overall space developments, and usually are done in association with many other technological breakthroughs. Starting in the 1980s, though, the space technology began to mature. Keep in mind that particularly in the United States, private companies were building things for NASA. About 80% of NASA's budget has always gone to private companies, even though they were under contract to the government with specific goals, specifications, and all the rest. But around the 1980s, you began to see where companies could also provide products and sell them on the market, particularly remote sensing in those days, but it was premature. Telecom grew faster, and DirecTV is still the major financial revenue creator in space. And that didn't mature till the late 90s. But what's changed in the last 20 years or so is that the civil economy has become more dependent on space, and this increases almost every year. And we get in our cars, we use the navigation. We turn on the TV, we see the satellite weather pictures. And of course, space capabilities are directly related to everything from TV distribution terrestrially to the backhaul and cell phones and many other very important things in our economy. And this is growing, and we are getting, and that's going to continue to grow. And so we are, again, going back briefly to the 1990s. And so a lot of this dependence really grew because we developed security and military type dependence on space capabilities. And a lot of that knowledge is now transferred. And as I mentioned, to the private sector, and that will continue to grow. And as consumers, we're growing in our dependence on space. We don't want to turn those satellites off. If we do, there would be significant disruption today. And that, I think, is going to continue into the future. Let's take very briefly 3 future scenarios. One is, I call it the space cadet one, where we're going to have people up there in cities and interactions in space and all the rest. Extreme optimism about what we can do in space. The second is much more moderate, continuous growth, pretty much similar to what has happened over the last 50 years. And the final one is that we have limits. We may find real limits on that growth and constraints as we move to the future. Also note, Jean-Jacques made the point, Companies are terrestrial, profits are terrestrial, economic measures are terrestrial, and even conflicts are conflicts between nations here on Earth. I don't think we're going to have a war in space, a space war, a Star Wars type environment. But if we don't contain our disputes here on Earth, certainly space assets are critical infrastructure. They will be involved, and we have to protect them as well, which will be and is a continuing concern, as our economies are part of national security just as much as our defense structure, and becoming more so. So I think the likely scenario is that past trends will continue. Telecom is going to continue to be important. Maybe not, maybe the growth will be there. Maybe spectrum and limits on what we can do with telecom will slow that growth into the future or make it more expensive. Navigation is a shorthand for PNT, position, navigation, and timing. Timing may be the most important consideration in future growth. It's behind a lot of all of the dependence on Earth from the distribution of electricity and water and a lot of things that we did that have, where space is responsible for improvements in the productivity and efficiency of doing that. But again, we've designed our systems to be dependent on those things. Remote sensing has been growing. There may be limits. How many pictures do we need? What other things can we do with remote sensing? We're seeing companies with great ideas out there, but maybe there's a limit there. Space exploration, government expenditures are going to continue. We're curious. And of course, as we go further out to the moon, to Mars, beyond, the private sector will be supporting that. And of course, we'll be dependent on government expenditures. Resource development, I think, is a big question mark. I won't go into that now. It's another separate long topic, but certainly we're going to try. So what are the problems? Jean-Jacques mentioned it. Markets, where are they? Where are these new markets? Where is all the money coming from? Cost of access to space. Yes, it's cheaper to put a small sat in space, but, and it's a big but, really the cost of a launch per kilogram has been reduced, but not by orders of magnitude. It's still very expensive. Space is still very risky in many, many aspects. We have legal and regulatory issues that have been sort of referred to before. I can't go into those because of time now, but they exist and we have to deal with them. And then just generally the political and economic stability on Earth is important. My best guess is we'll have the growth of business and government partnerships for new space opportunities. We'll have some stabilization of private investment. When there's a lot of risk, we have bubbles, we have disappointments in many of those, and it's a cycle. These things will happen, but I think we're still on a trend that's increasing in terms of private investment. Also with risks, particularly of new starts, with people with good ideas, we'll see more consolidation of companies. There won't be quite as many out there. And we'll have more concern about the vulnerability of spacecraft, whether it's debris or other things happening in space, and for the risk of terrestrial alternatives to do some things. We can do navigation, for example, terrestrially. It's just very expensive and not global and not as efficient. But that may improve. High altitude platforms, many other things are possible that will take these markets from providing those services. And if you do it terrestrially, you have usually less risk. And just quickly, some areas I think of promise for the future. The information economy is going to grow. We're reliant on that. Space plays an important part. A number of interesting developments are occurring in artificial intelligence and robotics. There will be the support of government deep space exploration and more research and development, and of course, the support of national security and also space sustainability. All these are market opportunities. Many of them are not just commercial, they're dependent on government expenditures as well. My time is probably over. I will quit there, but I think future space can be exciting, but there are risks, and the economic growth is not a guarantee. Thank you.
Thank you very much, Dr. Hertzfeld. I think it's a very good alignment with Jean-Jacques Tortor on this one. The next speaker is Bill Kemp. He's the co-founder and CEO of United Space Structures. And he will be talking about the human settlement and industrialization in space, planning priorities, and main challenges. I think that especially in this case, it's a very interesting subject. I mean, the USS has designed 4 different architectures and robotic systems for constructing large structures, either on the moon or Mars. And it'll be interesting to hear what are the developments on this field. Bill, please, the floor is yours.
Thank you, Marcus. I appreciate the opportunity to speak with you all. I hope you all are well and staying safe. United Space Structures, USS, has developed some patented technologies that allow for a construction process on the moon. And we intend to start building our first structure and have it occupied by 2031. These structures are large. They're 17,000 square meters of interior space. It's a 25-story tower that's located within a lava tube. We have a website. It's United-Space-Structures, if you want to see what I'm talking about while we're speaking. United Space Structures is a design, construction, and real estate development company. We intend to design, build, and construct our facilities that can hold hundreds of people and at a time. And the idea is to have a variety of different tenants that will stay at our facility for as long as they would like. And those tenants include tourists and scientists and lunar miners, and my background is mission critical facilities. And so I've designed a lot of data centers. And so we're going to be building data centers within each of our facilities, not only for lunar activities, but also for activities for Earth, for ultra secure data storage or processing, so that they can have access to that capability regardless of what's happening here on Earth. So we're talking to a lot of data center owners. We're talking to a lot of mining companies here on Earth, the goal is to create this lunar economy that is very robust and something that we want to invite everyone to participate in, regardless of whether you're a country or a company. We'd like to invite you to come because the idea is to create these facilities and then long and short-term lease these facilities to a variety of tenant types. Now, we're looking to find funding from private industry. We're not really looking for government funding. It's not that we don't want to involve them. We definitely like United States and other countries to come and stay at our facilities. But we think that there's a good use case for having this privately funded which will help to streamline the speed of this capability. And we believe that, you know, there's a commercial application for this, because our projections right now, because of the scale of our facilities, holding hundreds of people, we believe that we can generate $42 billion a year for each facility in revenue. And so once we get the first facility up and running, we're going to build many more on the moon initially, and then on Mars. So the idea is to create, again, a very robust lunar economy for everyone, so that we can do and explore all the things that we need to do. We're going to be mining the moon. Our companies, that our tenants that are going to be mining the moon, they're going to process that material, they're going to manufacture things, and then we're going to either use it on the moon, or we're going to launch it into lunar orbit, where we can then build other things, the infrastructure for expanding out into the solar system. So fuel depots and communications, satellite systems, and everything that's required in order for us to move out and eventually go to Mars. Our technologies will also work to build structures on Mars. There's also lava tubes there. But in addition to our lava tube architecture, we've also come up with two other architectures that could be built on the surface, large structures holding lots of people. And so we're no longer geographically agnostic. We are now geographically agnostic, because we can now build those on the North Pole, the South Pole, the backside of the moon, the front side, wherever you want to go on the moon. We're going to be able to build structures to allow people to do what they want and need to do. So United Space Structures is we are, you know, planning on doing this, and we're fundraising at this time. We're talking to several funding sources, and as soon as that activity is complete, we'll start our research and development, and we will start building our systems. So thank you for the opportunity.
Thank you very much, Bill. Certainly, I mean, this is an area I wasn't aware, and it's very interesting. Thank you. The next speaker will be addressing a different subject now. It's the militarization and weaponization of space and consequence for international security. We are going to have Dr. Rajaswati Rajagopalan, who is a distinguished fellow and head of the Nuclear and Space Policy Initiative Observer Research Foundation based in India. She's also a senior Asia defense writer for The Diplomat. And prior to joining the NCSS, Dr. Rajagopalan was research officer at the Institute of Defense Studies and Analysis in New Delhi. Please, Dr. Rajagopalan, the floor is yours.
Thank you, and good morning, good evening to everyone. For simplicity's sake, let's keep it as Rajagopalan. Please don't struggle with my full name. It's a little tongue twister. So anyway, thank you for the opportunity to be part of this conversation. There have been very interesting panelists and remarks already being made. So let me just get straight on to the subject, looking at the militarization of space and what does it mean for international security. So clearly, I think first and foremost, I think it's important to draw the distinction between militarization and weaponization. In many ways, it can be said that outer space has been militarized ever since the first communication satellites was launched into space. Militarization primarily refers to the use of space assets for a number of terrestrial military applications, and most militaries around the world are today using outer space assets for a number of functions, including monitoring, surveillance, command and control, early warning, navigation, and communications, and so on and so forth. Weaponization of space, on the other hand, refers to space or ground-based weapons targeting assets in space. It can also refer to weapons being placed in our orbit targeting assets on Earth. In fact, these have figured prominently in recent space security discussions. In fact, even at the last GG, the UN group of government experts on PAROS, Prevention of Arms Race in Outer Space, of which I was a member as a technical advisor to the group. There were enormous amount of discussions on this particular aspect as to how do you even define some of these aspects. So again, there are no globally accepted definition either for space weaponization or militarization in a sense. The fact that we do not have a globally accepted definition on many of these key terms and terminologies have been part of the problem in even ideating possible solutions to these problems. So let me touch upon how the understanding of militarization, for instance, has changed over the decades. For instance, in the 1950s, for instance, the time of the launch of the Sputnik and so on and so forth, the major powers, especially the US and USSR, emphasized peaceful uses of outer space, at least as far as their official rhetoric is concerned. And these during the initial years, as reflected in several of the UN resolutions on outer space, meant non-military in nature. However, after the US and the Soviets launched their early satellites, and the US interpretation also kind of began to expand to mean non-aggressive, and by then even the Soviets had come to accept this particular understanding. By the 60s, in a sense, you are seeing a broader interpretation of peaceful use of outer space, and that was becoming acceptable to both of the major players in it. And I would say that this is a dangerous and slippery slope, because today, if you look at it, the debate and the distinction between these two terms, the militarization and weaponization of space, continue to be even more vague than ever, and states interpret these terms as per their national interests. In the absence of clarity, definitional clarity of what constitutes a space weapon, this understanding has become further broadened to mean non-destructive in nature. Therefore, while treaties and mechanisms have articulated non-placement of weapons of mass destruction in outer space, development of counter space capabilities, for instance, whether it is anti-satellite capabilities or cyber and electronic warfare in outer space, with an apparent non-destructive use, is considered as acceptable in a sense. And absence of global understanding and common interpretation could, I think, spur greater insecurities in future, even as the definitional aspects of these terms continue to be an issue to be dealt with. Space weaponization has the potential to become real, with renewed ASAT tests over the last few years now, after a gap of nearly 2 decades in a sense. There are also the proliferation of small and mini satellites, and of course, like I said, the new counter space weapons and capabilities in a sense. And meanwhile, I think in terms of the lawmaking exercise, how do we control this process and so on and so forth, I think there is huge amount of skepticism among the Western powers, such as the US and others, that China and Russia may be pursuing arms control measures, such as the draft treaty, the PPWT, the draft treaty on the prevention of the placement of weapons in outer space, as possibly a diplomatic cover for their own kind of continuing military space program. And those are actually fueling further insecurities. In fact, Beijing has a flourishing military space program under the PLA leadership. Chinese capabilities, again, are primarily being developed vis-a-vis the United States, recognizing the critical US dependence on satellites. They have, of course, developed a series of counter-space capabilities to degrade, damage, deny use of space-based assets to adversaries, especially global communications, navigation, and coordination between nations and armies, and so on and so forth. They have the direct ascent ASAT capabilities, co-orbital anti-satellite systems, computer network operations, ground-based satellite jammers, directed energy weapons, and so on and so forth, both to undertake hard attacks like the kinetic methods to inflict permanent and irreversible destruction of a satellite, or to ground support infrastructure, or even undertake soft attacks by using non-kinetic methods, causing temporary damages, and so on and so forth. I would say that China's own preference is to undertake soft attacks, which may not, at least from their perspective, may not escalate into larger conflicts, and also it gives them plausible deniability when using cyber measures and so on and so forth. They have developed a number of other capabilities, and they have also been demonstrating the ASAT capability on a much more frequent basis, although they call them mostly missile defense tests and so on and so forth. And of course, I think Russia's recent actions, again, they have been worrying, and they are not lagging behind. On July 15th, 2020, for instance, they injected a new object into orbit from another satellite, the Cosmos 2543, in close proximity to another Russian satellite. Again, this is not the first time that Russia had undertaken such an action. In 2017, they had a similar operation being done, where a Russian inspector satellite, Cosmos 2519, released a sub-satellite, Cosmos 2521. So these actions, again, are coming up on a much more regular basis. So even though neither of these actions did sort of create any debris and so on and so forth, the fact is that there are serious doubts about Russia's even rhetoric about the non-weaponization of space. If these activities continue unabated, it will only further intensify competition among the major space players, potentially leading to weaponizing space. The space security regime is already in trouble, and the Russian actions and even the Chinese actions, which are triggering more further spiraling kind of reaction from the region. For instance, India's own anti-satellite test in March 2019 was a result of okay, there's a chat. Okay. Okay, I'm running out of time, I believe so, but let me come to very quickly to the possible consequences. So my quick question is deterrence in space, is that going to be the policy? In the absence of successful multilateral efforts, states will be forced to rely on deterrence as a mechanism. Deterrence effects will cascade, because if one state relies on deterrence as a method, as a policy, others are going to follow that same suit. And the net result is that there are going to be consequences which is going to be negative for all. Leading to increase in suspicions and making cooperation further difficult. Right now, deterrence as a model is not a state policy for any country. So there is a possibility to prevent it, but that also means that we need to have multilateral negotiations. And I think that's a starting point, starting and the end point in a sense. We don't have a sort of a consensus at this point of time. The failure of the UNGG in 2018, 2019, to the point where the group could not even come out with a consensus report, talks to you loud and clear of the problem of decision making. The failure of developing consensus among the major powers is going to remain a stumbling block for quite some time. And I think these insecurities will only further accentuate the insecurity sort of weaponization trends that we already seen. Given the paucity of time, I'm going to stop here, and I'll be happy to take on any questions. Thank you.
Thank you very much, Dr. Raji. I think it was an interesting change in the subjects here, and for me, even things like the difference between weaponization and militarization is interesting to think about it in this sense. Thank you. We're sticking to the same subject, and I'd like to invite Dr. Bladin Bowen, who is a lecturer in international relations at the University of Leicester, based in the UK. Dr. Bowen is the author of War in Space, Strategy, Space Power, and Geopolitics, and is an academic expert in space warfare and space policy. Dr. Bowen, please.
Hi, yeah, thank you very much to everyone at Trends for having me here today. It's good to see a few familiar faces here, and Raji is always a difficult act to follow. So thanks very much for outlining that distinction between militarization and weaponization. That was really good, and also I'm glad to see that it's also what I was telling to my students earlier this week, because I just spent a few hours this week talking about the military developments of space technologies for my students here at Leicester. So I'm glad we're on the same page there with militarization versus weaponization. So in the time I have, I guess I'm going to do the academic thing and complain about terminology. So like Raji, been asked to talk about militarization and weaponization, and there's just so much baggage with these terms that they often obfuscate understanding, let alone sort of finding solutions, which is what Raji alluded to earlier. And I guess I'll just go through sort of my own view of what those problems are. And the first is not so much with the substance of the meaning of militarization, because in the way that Raji explained it, that's what it is. It's a fairly sort of mundane reality of space has been used for military purposes, for terrestrial military forces, since virtually the dawn of the actual space age itself. And that's a fairly uncontroversial, practical understanding of what it is and how most military forces around the world have understood it. The problem with militarization is the way it's spoken about in public fora by officials, by journalists, and by amateurs. Even in arms control fora, you have rhetoric that says we need to prevent the militarization of space. Now, that deliberately ignores the reality, especially when it comes from the officials of countries who have militaries that are using space for military purposes. So in any practical definition of the word, we're not helping ourselves in terms of those of us in the space sector, but also in communicating the actual issues to wider populations by using such language irresponsibly, by not actually accepting that the militarization of space has happened for a very long time, and it's not slowing down. It's only spreading to more and more militaries, and military space power is only proliferating horizontally and vertically. And there is no appetite whatsoever amongst the modern military powers for undoing any of the technological advances in space over the last 60 years, unless there's some amazing new terrestrial alternative that can take their place. So there's a lot of concern about the militarization of space that is ignorant of the reality, which is we've been using space for military purposes in terms of the most modern military powers for a very long time, and the world hasn't ended. And you saw a lot of that rhetoric in the response to the creation of the US Space Force last year, or 2019, in the United States by Donald Trump, where fears about the militarization of space, well, it's like fearing that the sea is wet, to be honest. It's always been military, and the Space Force is not inherently new or dangerous in that regard, in terms of the actual duties of the US Space Force. It's just doing what the US Air Force has done for a very long time, which has both benefits and negative implications depending on what they do for strategic stability. So militarization is a really problematic term in the way it's used by a lot of communities, rather than the substance. Weaponization, however, is a worse term that I have more problems with for the same reasons Raji mentioned earlier, is that there's just really no agreed understanding of what it actually means, but also the way people use it are strategically illiterate as well. So there's a threshold quality given to placing weapons in orbit that are not warranted. Somehow the belief that if you put weapons in space, you will control the world. That there's a point of no return for international relations and international security if somebody puts weapons in space. There's a lot of that alarmism that the greatest threat to international security is weapons in space, which that's not the reality of the situation. Space weapons aren't the most effective weapons that humans have ever developed, and if they were, they'd have been deployed back in the Cold War at scale. There's a reason why America and the Soviet Union explored a lot of space weapons technologies in the Cold War and never really were that interested in them, because they're really difficult. There are lots of limitations to orbital weaponry. They only have marginal uses in very specific situations against very specific targets. So in terms of modern warfare, space weapons have very limited and specific utilities. They're not this sort of world-changing, strategic balance upsetting function. It's sort of in the same way that people still think that mid-course missile defense works, which it doesn't. So there's a lot of strategic and technological illiteracy around space weaponization that takes people away from understanding what the genuine problem is and where can cooperation and understanding be built. So the devil is in the detail, really, because there are many kinds of there are many negative effects that people ascribe to space weaponization that can be achieved without putting weapons in space. So all the debris generating events that everybody cites in such presentations, they've been generated by Earth-based anti-satellite weapon systems. They're not based in Earth, so not based in space. So in terms of actually generating all the bad consequences of space weaponization, we sort of already can do that if we really want to, or at least those with space weapons capabilities. So those hard kill weapons, it's like, well, you can do those with kinetic systems or nuclear weapons if they really wanted to. And also the states that do have those kinetic weapons are also nuclear weapon states. So there's the risk of nuclear escalation in those contexts as well. And who really cares about machines in space when you have potentially millions being vaporized on Earth and a possible nuclear winter? So there's a certain perspective that needs to be remembered in terms of major interstate conflict and space weapons, because if we're looking at that, then we can't really ignore the prospect of thousands and hundreds of thousands of people dying on Earth. So there's that larger perspective that needs to be remembered, because it's in the larger military balance between the major powers under the thermonuclear revolution. And then there's also the historical reality that the Soviet Union did test and deploy various kinds of space-based weapons in the Cold War in the 70s and the 80s. The sky didn't fall. The Soviets tried it, and they were of marginal utility and use. The Americans did not start a war over it. There are ways back from doing things as well. So just because, even if, say, Russia deploys some of its old Soviet legacy systems tomorrow in space, if it revamps the old IS system, it doesn't mean that there's no way to come back from that either. So to balance my more doom and gloom messages now, it just means if you do deploy weapons in space at some point, it doesn't mean that you can't then undo it. Technologies are as much a part of human social construction as anything else. So if we want to roll back things, we have to try and build the political will and understanding to do so. So the solutions then for me really is about getting away from these two big terms and starting to identify the specific activities or weapon systems that we don't like, or we or you being practitioners, organizations, civil society agencies, private companies, or researchers. So I will leave you with sort of two questions that I hope sort of get beyond the problems I see with militarization and weaponization of space. One is, what specific military activities do you not want to see and do not want to see happening anymore? What specific activities? Second, what specific weapon systems or techniques do you not want to see? There are some of those you might be able to build some consensus on and others not. So you might be able to get some consensus on some form of anti-satellite testing regime or rules or guidance for best practice. So no intercept events over a certain altitude. But you're not going to get any agreement on soft kill anti-satellite weapons like electronic warfare, jamming, or cyber warfare. Those would be much more difficult to monitor and verify and prevent cheating. So once you start breaking things down into activities or specific weapon systems, then you might be able to start getting somewhere. And that was one of the benefits of the INF Treaty, because it didn't ban things based on classes of technology. It based things based on the actual systems that have been built and deployed. So hopefully, if you get more specific and move away from the big weaponization, militarization terms, you might actually get somewhere and start finding very specific areas to try and do something in an area which Raji reminded us where there's been so little progress, meaningful progress to date. So I will leave that academic wine there, and thank you very much again for listening so patiently.
Thank you very much, Brady. I think it was a very nice compliment to Dr. Raj's presentation. I think it seemed like you worked together on this. Thank you. For the next session, we have a new era of space innovation, the key drivers and strategic objectives on the horizon. And I'd like to invite Dr. Nithal Goswani. He is a professor of physics and astronomy at the American University of Sharjah, based in the UAE. He is an astrophysicist, has spent a couple of years as a doctoral researcher at NASA's Goddard Space Flight Center, and has conducted research at several top centers in the US and France. Please, Dr. Goswani.
Thank you very much. Good evening. These are exciting times, and so I am grateful for the invitation to take part in this very interesting and multidisciplinary panel. We are a week away from the arrival of the UAE's HOPE probe to Mars and orbital insertion. So everybody is really excited right now. There's going to be, as we were reminded, 2 other probes or spacecrafts to arrive at Mars. But I think the source of main excitement for me is really because I think we are living times with the greatest innovations in space, perhaps after the very first burst with Sputnik and the American program. I think right now, the innovations that we are seeing are really exciting for space science, for space technology, for space exploration. And so in the 10 minutes that I have prepared these few slides, which are just very brief ideas that I want to put in front of you with some pretty images, just like we do with presentations. So allow me to just show you some of the ideas I wanted to present to you. As I said, there are two themes actually to this presentation, or to this topic that was pitched to me and others. One is the key drivers to space innovation. So what is driving and what are the avenues of space innovation that we are witnessing right now? And secondly, what are the strategic objectives and the strategic pursuits that we are witnessing from the space players? Excuse me. For some reason, this is... So I think the first key driver to the space innovation is the big rockets that we are seeing that are going to be readied over the next couple of years. Some of them are slated for inaugural flights toward the end of 2021, this year. We have already seen reusable rockets, and that's a game changer, practically speaking, with SpaceX and some other commercial companies for sending spacecrafts and sending probes and taking astronauts to space are actually changing the game right now with innovative rockets. And I think that's a key development that we need to follow and see what's going to happen. Another one that was actually mentioned earlier by Dr. Goswami is these platforms at sea. So this gives a lot of flexibility because, as you all know, launching from different places on Earth has different challenges and different advantages depending on where whether you have spaceports which can allow you to launch toward the east or at a certain angle. Is there a sea to your east, etc. Now, with this idea of launching from sea, which has been demonstrated by SpaceX, China is just beginning to do it. And for certain, there's going to be other players that will start doing this very soon. And that will, again, change the capabilities of launching rockets to space. The third really exciting, but really fascinating, we don't know exactly when this will become possible, but SpaceX announced that they will want to use some of those rockets for ultra-fast travel on Earth. You can see the map that they have put together, and interestingly, Dubai is on the map, and there's going to be these very brief and very short trips that normally take 8, 10, 12 hours will be done in half an hour or a little bit more than that. And that's because there's going to be all these space innovations that will benefit us here on Earth. You can imagine if we start having flights between London and New York, or Dubai and Los Angeles, or Hong Kong and London, etc., in an hour or less, what kind of a game changer commercially and other this is going to have. Another key driver that I think is going to lead to important space innovations is artificial intelligence and robotic spacecraft development. I couldn't help but put HAL 9000. For those of you who likes science fiction will remember 2001: A Space Odyssey, and the intelligent computer that went crazy for all kinds of reasons. But we're going to really now benefit from artificial intelligence in not only developing spacecrafts, but also in conducting missions at a more effective and efficient rate, and with cheaper ways of doing that. In terms of strategic objectives, there's a few important developments that are going to take place over the next few years. One is this renewed interest in the moon. The Americans have already announced the Artemis project, and that's exciting in itself because there's going to be women astronauts at last that will make it to the moon. That is presumably slated for about 2024, possibly a little bit later. The UAE, interestingly, not just the spacecraft or the probe to Mars, which will arrive in a week's time. But also the UAE sent an astronaut to the space station about a year and a few months ago, just about 15, 16 months ago, and is now running the second cycle of training people to be astronauts and to be going to the International Space Station. And just a couple of months ago, the UAE announced that it will be sending a rover to the moon. That's the little drawing or painting that you see underneath it there, with this rover with the Emirati flag on top of it. And that's exciting because it tells you that now different powers, and not all the traditional space powers, including countries like India and China, Japan has announced the smart lander for later this year, probably in November. So the moon is now coming back to be a new again. It has been a long time since we sent astronauts to the moon, and we have been sending, China sent a robotic lander to the far side of the moon, and that was very exciting just last year.
Yeah, I did. Yeah.
So that's going to be an interesting development. Another strategic development that we are expecting to take place during this decade, probably a little bit later in the 2020s, is a human trip to Mars. This, I don't need to tell you, raises extraordinary complications. I was very interested in the talk that Bill Camp gave earlier with the structures and the new developments with lava tubes and so forth, because the main difficulty in trips to the Mars and in building on Mars and living on Mars, even for a few months, is the extraordinary amount of radiation, because Mars has a very, very thin atmosphere, 100 times thinner and less pressure than we have here on Earth. And as you can see on this diagram here on the slide, going to Mars, which takes usually 6-7 months, and then spending another 6 to 12 months over there, and then coming back, subjects astronauts to at least 100 times more radiation than they receive here on Earth in a typically similar time period, let's say over 2 years. And that kind of radiation is extremely harmful, obviously. And so we need to develop ways to have spacecrafts that can withstand that kind of radiation for extended periods of time, and also building on Mars and on the moon in protected shields. Last but not least, there is this commercial now interest and rush to take advantage of space mining of asteroids, also possibly space mining of the moon. And that poses legal challenges, technical challenges, all kinds of who's going to get there and who's going to share and what happens and so on and so forth. But technically speaking, at least this is exciting, because it means that we will have access through robotic spacecrafts that can land on asteroids and the moon and elsewhere. We'll have access to very rare elements, very expensive elements. And so this technical development is going to be interesting. That poses legal challenges and so forth. But I think this is going to be exciting time. So in very brief, I wanted to just sort of send you a few ideas here to show why I am personally excited in terms of space science, space technology, space exploration, even though I am aware of the many challenges that all of this is posing for us. Thank you for attention, and I'll be happy to listen to the rest of the presentations and to share in the discussion later.
Thank you very much, Dr. Goswani. I think it's certainly a very interesting area as well. I would like to invite the next speaker, who will talk about the new era of space innovation, the key drivers and the strategic objectives on the horizon. Same subject we had before, but now will be Dr. Yayan Abdul Samad, who is a senior research associate and senior teaching fellow at the University of Cambridge in the UK. Dr. Samad's research work is based on developing materials for electronics, health, and space-based technologies. Dr. Samad, please.
Thank you, Marcus, for the very kind introduction. And I'm really honored and happy to be among this esteemed panelists over here talking about futuristic challenges that we face in space and space research. And also, I'm really interested to know more about the policies, because as an academic, I'm not exposed to the policies as much, as much as we do research and kind of do science to resolve the issues and challenges that we have in space. So just like Professor Gassoum, I will also take the opportunity to share some slides. I think we academics are addicted to talking in slides. So I'll share a small presentation to talk about the points that I would like to mention here. So without wasting time on the introduction, so there has been, this point has been stressed enough that we have a plethora of work going on in the space sector, and there's so much happening around the world with smaller countries launching their space programs and doing so very well. So we have, with this advent of plethora of spacecrafts being launched for different missions and satellites being launched every other day, we have this plethora of challenges, which I call opportunities, because once you face these challenges, then when you come up with the solutions, then the solutions could be cross-cutting. And I think that the solutions have to be cross-cutting. Whatever we are facing in space, the challenges, we can resolve those challenges to implement similar solutions on Earth-based problems as well. So first of all, we are talking about interstellar movement. Why should we take a course from Earth to Mars when it takes a year or more? Why there cannot be better technology? So there are indications now that there can be better technologies with laser propulsion and some other technologies where you can basically reduce these interstellar movements. And I'll talk a bit about the solution later on. First, I would like to talk more on what problems are we facing. Professor Gassoum talked about radiation protection. I think radiation protection is not only in Mars, but in space in general. What do you do with all those manganese and iron and I don't know, God knows what kind of ions which are impinging upon everything that goes into the outer atmosphere, in space. So this is a big challenge of which need to be resolved for us to basically mine or to explore or to exploit the plethora of opportunities that we have in space. So I believe that this maybe is the biggest challenge that humanity is facing, the radiation that are coming from all over the galaxy. And if it's resolved, then a lot of things would be solved. So there are some of the operations on Earth which I believe should be shifted to space because we do not have so much resources on Earth. For example, we have a lot of cryptocurrency mining going on Earth, in the world, and you'd be amazed that the Bitcoin alone, the production of the Bitcoin and current Bitcoin production alone is consuming more energy than the energy consumed by Switzerland as a whole country, Czech Republic. It's like similar to what Czech Republic, the entire country it's consuming. So it's a lot of energy, and of course, with these kind of operations on Earth with limited resources, we need to exploit the resources that we have on space. And in space, there are opportunities. So we were talking about radiations, which are a source of heating as well in space. And the heating in space doesn't come only from the radiations, but it also comes from the albedo and electromagnetic radiations from the sun. And anything which is basically into the outer atmosphere, even if it's orbiting around the Earth, take for example a satellite, it is exposed to all these radiations. So these are all heat sources. So these are all energy sources. But then there's another blessing in disguise in space, which is the low temperature in space, which is about 3 Kelvin. So what do we need in order to produce energy? We need heat and we need a sink. So we have an infinite sink there, and we have infinite sources of energy. So what we need is to exploit this. So that's why I talked about some operations that we are doing on Earth. They need to be transferred to space, such as the cryptocurrency mining and others. So I'm a material scientist, and I'm working on materials. And one of the materials that I work on is these kind of 3D structures of a new material called graphene. It is one of the lightest material that you would find anywhere on Earth, but at the same time, it's structurally strong. It has some other properties, for example, radiation protection from electromagnetic radiation, especially X band and whatnot. And also it has many other interesting properties, which I'll talk about in a bit. So that's how these kind of structures that we develop for different applications in space, they look like when you look at these structures through the eye of a video microscope. Okay, so we have tested some of these materials. I don't have time to go into the science of what we have tested and what we have done, but we have tested some of these materials in parabolic flights. So this is a parabolic flight test done in 2017, and then another done very recently in 2019. So in these parabolic flights, basically we have tested these kind of materials for their thermal applications to exploit the energy, the plethora or the abundant energy that we have in space, which we can exploit. And then I mentioned that, you know, the operations such as Bitcoin mining and these kind of things, they should be transferred. And it is because of these kind of technologies that we're working on would be able to do those kind of things. So this is just a bit, this is a bit of science here. So we are basically measuring the evaporation rate, which is a thermal property of the graphene-based material that we are testing. So we are basically performing 8 times better than the traditional materials like loop heat pipes used in space. So I'll answer more questions if somebody has on this part. So we also tested some of the materials to counter check the performance that we have measured in a parabolic flight, and we haven't fully analyzed the data of this parabolic flight, which is a sounding rocket that we launched from the Kiruna base of European Space Agency and the Swedish Space Center as well. So we are basically trying to test this. So this is the first time that graphene was tested in space. Before that, graphene, the material, was never tested in space. And we have got quite promising results. And this is not it, because when you're talking about radiation protection, then, you know, the current materials, for example, a sheet of PET, which protects from radiation, many radiations, not all the radiations which are found in space, but many radiations. You know, the thickness of the normal PET sheet put into the suits of astronauts is about 15 millimeters. So if you talk about graphene, so we have this new technology which can basically do the similar kind of shielding as a 15 millimeter PET with only 2 millimeter of thickness. So we have a sheet of graphene along with a sheet of PEO, which is basically trapping some moisture, because moisture is a very good ion absorbent, and it basically can protect from a lot of types of radiations. And then we have a little sheet of PET. So in total, the thickness of this 3 sheets is 2 millimeter, but it can provide similar shielding as that of a 15 millimeter of a block of PET, which is currently, you know, state of the art, basically. So, and also graphene, there are some experiments, some preliminary results which suggest that graphene can be used to propel via a laser. So we can have structures of graphene, let's say a little satellite or a spacecraft made out of, structurally out of graphene. We can propel it with lasers from wherever we want, and there are some indications to that, and there's more research required, which we are basically doing. So these are challenges in space. And for any space challenge in space, how we work is that we believe that whatever solution we have for problems in space, there should be solutions to problems on Earth as well. So every technology that we build in space can be sustainable only if it's a cross-cutting technology. For example, if we are making a technology, it should be suited for across all applications from Earth to deep space. So this is, for example, the NASA Integrated Vehicle Health Management Roadmap. And I believe that all the technologies that we develop should be based on a similar strategy, that whenever we develop a solution for space, it should be cross-cutting. It should be solving the issues in space as well as on the Earth. For example, the heating devices that we make, they're capable of being used on Earth as well for applications like railways and computer processors and whatnot. So that's it from my side. I'd like to take this opportunity to thank my collaborators and people that I work with. So I'll be happy to listen to other speakers and answer any questions if somebody may have. Thank you.
Thank you very much, Dr. Nidhal. I think the point that the technology has to be something we can use across different applications and industries is certainly a key one, because space is still niche. You have to develop things that can be used to have a wider usage. So thank you very much for the presentation, for the insights. Now I would like to invite Dr. Ivan Danilin to talk to us about commercialization of space travel and tourism, from science fiction to reality. He's the head of the Science and Innovation Department at Primakov National Research Institute of World Economy and International Relations, and part of the Russian Academy of Science. And his area of specialization is the USA and Russia's innovation policy, digital economy, and digital transformation policy. Dr. Danilin, the floor is yours.
Thank you very much, Mr. Moderator. First of all, let me thank you for invitation for this forum. It was and still is very interesting and challenging. And let me now share my presentation. Can you see it?
Yes.
Okay, that's great. When the organizers contacted me considering this topic, commercialization of space travel and tourism from science fiction to reality, at first I thought that it would be much more correct to call it from fantasy to fiction. But now, after some additional studies, since I spent about 2 years studying the space economy issues also several years ago, I think that the more correct answer would be from fiction to futures. So let me give you a very short overview of the history of this question. So we'll remember that the first attempts to organize space travel relates to the late 1970s. At first, it was much more about the geopolitics of space, or astropolitics, and about space missions. And the first among these programs was Soviet Intercosmos, which started in 1978 for the countries of the Warsaw Pact and so-called third nations like India and so on. And of course, US Space Shuttle, which also was important for bringing astronauts and researchers from other countries to space. But already in the middle of the 1980s, it became obvious that there should be some more engagement of general public, of researchers, of science in the space missions. And one of the most brightest initiatives in this case was the program organized by the Reagan administration, by NASA, so-called Teacher in Space. It should have been more correctly, at first among a series of different programs alike, like, for example, Journalists in Space and so on, but it was effectively dead after the Challenger disaster, and so it was a dead end on this for this period. However, the first successful non-astronaut commercial spaceflight appeared in 1990s, and this was not what in most cases mentioned in this case the flight of Dennis Tito. It was the Japanese journalist Toyohiro Akiyama, who spent several days on Russian Mir orbital station. In this period, it was Soviet. And it was a kind of a celebration by the Tokyo broadcast system of its 40 years jubilee. And so it was, in many cases, a kind of a mix of research, publicity, and commercial missions for this time. In 1990s, so we have different commercial scientific research missions on Mir orbital station, and then goes the space tourism. In fact, both the Mir program and the space tourism was not about the business, or more correctly about the space economy, but about the resource restrictions by the Russian space program. However, in 2001, it's this time when first official space tourist Dennis Tito, an American billionaire, visited ISS as a part of Russian crew, and then up to 2009, 8 missions and 7 customers, one of them get to the ISS twice, opened the era for the space tourism as a kind of a new market. However, even in Russian literature, this period is called sometimes a false start for the space tourism market. Not because it was not a business, but because it was not a market yet. Because there was very specific conditions under which Roscosmos sent the tourists to the ISS, and it was still, I would say, a kind of a forced solution rather than the business activity. New dawn for the space travel and tourism appeared in the early 2000s and especially in 2010s with the rise of several important trends in the global economy, space economy, and space technology. First of all, of course, some technologies become more sophisticated and, what is not less important, cheaper. The key thing here was the new generation of startups appeared to commercialize. Some of them may be called dreams or childish fantasy, depends on your point of view of billionaires like Jeff Bezos or Elon Musk. But also it was a kind of a new requirements from the new generation and new markets for what may be called the experience economy. This is, in my eyes, one of the most important trends for the space travel and space tourism for the years to come. So just imagine of taking selfie for your Facebook account somewhere in the orbit. It would be important for your subscribers if you are, for example, an influential blogger or celebrity. And this constitutes a new market for this kind of a business activity. For example, for Virgin Galactic is said to have about 600 to 700 customers already booking flights for the about 90 kilometers above Earth, and it would cost about $200,000. It's still very close information about some financial and other details. And it now looks like something like really a market. An important additional trends was privatization of space and NASA activities, and this is, I guess, the second time in the history of technology when one public agency supports a new startup market. The first one, I guess, was in 1950s, 1970s, 60s with the DARPA. For NASA, it was also like, not very like Roscosmos, of course, but in the same logic about the economizing of the costs. So NASA, since the late of 1980s, was obliged to support the private missions. In 2000s, with the very ambitious projects for return of Americans to Moon and then to Mars, there was a new issue of lowering costs both for the launch activities and for the different operational functions. Here we have COTS and some other programs which effectively support the above-mentioned startups. And an important accent that was, as far as I remember, put since the George Bush Jr. administration to seize the ISS program in favor to free up needed resources for interplanetary missions. These two factors resulted in some technological and business activities that we all know quite good, and again, which is not less important, stimulated some global competition. So that may be labeled as techno-national. I don't want to say that other nations just think about, catching up or overcoming United States because NASA or Elon Musk does something. But still, for example, for China and for Russia, it was an important stimulus in development of their commercial activities. And of course, as a final trend, there was a global middle class rising all over the world. So the new generation of customers in the experience economy with armored with different Facebook, Instagram, and some other accounts are ready to go to the orbit. So here I place several groups of companies and sub-market sections that are already in place for the future, mostly, of course. But what, for example, makes me especially interested, so the fact that we are now transferring from the pure touristic issue considering the space travel, space touring markets, to the new markets of entertainment, media, and so on. A kind of a first signs of it is the contract of NASA with Tom Cruise to visit ISS. I think that James Cameron would not lose this opportunity as well somewhere in the future. So there is an Axiom, this is American startup project with the Space Hero TV production company contract to place the some participants of the TV reality show to the ISS and maybe further to the Axiom own space station and so on. And this also makes us sure that these markets became more sophisticated and differentiated. So there's different estimates of how this market will grow in the decades to come. I'm a bit skeptical about all these progressions, not because I don't believe in space economy and so on, but I'm always very hesitant with these kind of projections. And so what I would like to say is that the differentiation of the market that is going right here, right now, is a much more important trend that will define the future market for space tourism and space travel for the period up to 2030s, maybe up to 2040s as well. So some of them are more or less obvious, and this is orbital tourism and entertainment, as I put it earlier. But it seems by some signs that there may be some additional markets for research, education, and popularization of science. And here we have both universities, national agencies from the developing countries as well, and so on. We may see some signs of the possibility of this market, considering the efforts by, for example, university and other academic institutions in launching the experimental satellites in space, and possibly the industrial research and experiments. So I made a kind of a small expert interview preparing for this presentation with the Russian space experts. They say that as for now, there is not that much room for the new industrial R&D on the orbit, but possibly the development of new materials, new technologies in 2020s, also in the pharma sector, would drive the new interests of the big corporations and maybe some small and medium enterprises for the zero gravity and other experiments on the orbit. I would not, say too much about the different exotic uses, like, for example, colonization of Mars and Moon. So the future will, define it for us. And so let me end the presentation with the most beloved by all academic researchers issue of challenges to come. So first of all, I guess this is obvious, this is technology, and this question was already highlighted here on this forum. And this is not only about the cost of the flights, but also about the safety. As for now, for example, collision with space debris is not that much a problem for the spacecrafts, despite it's still a threat. But when the orbit and suborbital space would be crowded somehow somewhere in the future by the small commercial spacecraft, it would be a challenge, and then we'll have to build up a new system for the prevention of collisions and so on. Of course, there's a question of economy, because once again, as it was mentioned, we should make business from space business. And what is most important, but quite obvious, this is regulation. As for now, we have, let me say, a kind of ad hoc regulation, like it is so in the United States, where the regulatory function for the commercial space flights are focused on the Federal Aviation Administration. But I guess this is a kind of a timely and not permanent solution. But we have all the issues considering international laws, harmonization of national laws, standards, and so on, including the liability issues. And this seems to be a very hard job, especially in the era of technology and trade wars. Also, there's a problem of who wants to be a regulator. So it seems to be obvious that the state would play an important role in this issue. But also there would be, I guess, a challenge of building the industrial association for the standard setting and about the role of NGOs. Geopolitics, space or astropolitics seems to be also a problem for the years to come, because we see what is going on in the relationship between the United States and China. In Russian, there is a problem of Russian foreign policy and reactions on the West and so on. And it would also make some problems for the development of the markets. And finally, the issue that was put by our first speaker, our host, this is the question of values. So as for now, it seems to be a secondary issue, but I guess that in the years to come, when space will become a fully commercial service for tourists, for, researchers, and so on, there would be a big problem of how to support ethics of these space activities, inclusiveness, role of the developing states, of minorities, and so on, because the picture when only white millionaires flying into orbit seems to be a good business, but maybe not that much an ethical case. Thank you very much for your attention. We'll be happy to answer your questions.
Thank you very much, Dr. Ivan. I think it was a very interesting presentation. We are a little bit behind on our schedule, but I think it would be a shame not to have even a single question to get the forum to give their views. We received a question which basically is how can the world benefit from space exploration and the increased participation of private companies in the sector? I think we dealt with so many different subjects here. This question is probably one that you can find ways to apply to most of the subjects we discussed. What I'd suggest, and if you're happy with, is that I'll ask each of you to just give me like a 30 seconds, 1 minute view on your insights, your opinions on this. So I repeat, the question is, how can the world benefit from space exploration and the increased participation of private companies in the sector? So you look at it in the context of your presentation, and so that we don't have I would suggest I'll start from the last. I'll start with Dr. Ivan. He was the last one to present, so he'll be the first one to give his views on this question, and then I'll proceed in the reverse order. After Dr. Ivan has given us his view, I'll go to Dr. Samad and so on. So Dr. Ivans, it's very short notes, but so what are your views on this?
Well, let me be really very short and both say emotional and economical. First of all, I guess an important thing is inspiration, because there's something important that we lost in 1990s and early 2000s. So as one American venture investor told us that we dreamed about the flying cars, and What we get is just several symbols in tweets. And this is a very important thing for the new generation of scientists and engineers. And concerning the economic part, I would say that there is a very dull but very important issue of spillover effects. So we all know how the American Soviet space program affected the technological development in different areas, from computers to the material science. I guess that space travel and space tourism, as well as all other directions of market and technological developments in this area, will be very important for the future emerging technologies and the future economic growth of all nations, and especially for the space newcomers like for example, Arab Emirates or Malaysia, Indonesia, and some other nations. Thank you.
Thank you very much, Dr. Ivan. Dr. Samad, could we have your 2 cents?
I think it's a very common question that I get asked, and you know, people fail to understand that this space research or the developments in space have already benefited the Earth a lot. Although when the first space race between the US and the USSR then and Russia now, it was basically, you know, more of a defense space war, but then even then it, you know, benefited the humanity so much from the internet to, you know, the weather information and whatnot. So we have a lot of things that are coming from, you know, the space research and as a result of exploration. But now, when we talk about research at this point, you know, we should bring sustainability to exploration and space research as well. So how do we bring sustainability to space research? It lies in the vision. So we should have a vision of doing those kind of exploration or those kind of research, which is aimed at benefiting the humanity on Earth. So when you do exploration with this vision in mind, or the goals are set such that any technology which is built for space should be useful for the humanity either on Earth or elsewhere, then you know, we can really develop technologies which will help us not only explore the deep space and what lies out there, but also to get that information and use the same technologies on Earth to you know, improve our lives.
Thank you, Dr. Samad. Dr. Gesum, could we have your views, please?
Yes, thank you. Well, briefly, I tell people that first of all, we cannot live without satellites today. It's obvious. We need them even on an everyday basis for GPS. We need them for weather planning. You can see the storm that's raging in the US right now, and people are dying. And if it's not for satellites that can tell us exactly how the storm is moving, etc., there will be a lot more deaths just because we do not know what is happening on our Earth, and countless other examples where space technology and space science are vital to humanity today. Number two, space technology leads to more space science, or more science more broadly. Science leads to more ideas, and these ideas can cross borders, cross branches, go to other fields, and develop into medicine, develop into water resources, develop into even just, you know, our cultural development, our understanding of each other, understanding the climate, the earth, the ecology, and so on and so forth. So I think we need to emphasize that science, technology, human flourishing, human culture all go hand in hand, and nobody should demand, you know, immediate benefit from one thing or another, because then we do not make progress. Progress is all collective, and one thing leads to another, sometimes in a non-linear manner. I think this is the message that we need to get across to everybody.
Thank you. I think it's certainly very good points as well. Dr. Bowen, would you be able to give us your views?
Sorry, this is going to be very downbeat. I mean, the most important thing that could possibly come from space science and technology in general, or even dreams about space exploration, should be geared towards trying to prevent complete and utter ecological collapse on Earth and resource exhaustion. I mean, we're on track to losing hundreds of millions of people by the end of the century through collapsing food systems, loss of biodiversity, rising sea levels, take your pick. Space technologies are essential for that, and I find it abhorrent, really, that people want to go to Mars whilst they're busy making Earth uninhabitable as well. So space technology should be at the forefront of most efforts to try and stop this world from becoming as barren as Mars. So I don't know why people want to go to Mars when we can't even properly live on Earth to begin with, and Earth is far more hospitable to humans than Mars. So I'd like to see that space technology be more geared towards, and space exploration geared towards, helping address the actual imminent disasters here on Earth of our own making.
I have to say I agree with you, and there is I don't want to spend too much time, but there is one point that I always get, even though I've been in the industry for 40 years, I should love satellites as I do and everything. When people talk about the clearing orbit debris, I really think people should start on the oceans. But it's of course, there are reasons to try to clean everything, but we should look at the priorities and where to start. I think it's a good point. Dr. Raji, would be interesting if you could give your views.
Thank you. Absolutely.
You.
No, space exploration must and will continue for a good number of reasons. One important point being that a number of developing countries are just beginning to appreciate the use of space in changing their lives. But we need rules of the road if we have to be able to ensure safe, secure, sustainable, and uninterrupted use of space. And I believe private sector must have a space in developing rules of the road, standards, guidelines, and so on and so forth. But this is not going to be easy, especially when you look at the space security debates or the space weaponization context. But I think we need to find innovative ways of using the private sector perspectives, maybe through their voices through national governments. So we can find innovative channels through which the private sector perspectives can be incorporated as part of the national debates, national perspective when it at the global governance debates and so on and so forth. Second, very quickly, given the growing space weaponization trends that you're seeing, I think private sector has a huge role to play in building better redundancy, hardening of space capabilities, and so on and so forth, and enhancing, of course, the security of backups and so on and so forth. So I think private sector can play a very useful role in ensuring the safety and security and sustainability of outer space. Thank you.
Thank you very much, Dr. Raji. Bill Kemp, it would be interesting to have your views. You come from a different side.
Well, I think, we're living in pioneering times as far as space goes. Even though we started it 60 years ago, we're still at the very beginning. And pioneers tend to band together to work together. And USS is hoping to build facilities in which many countries and companies can come together and cooperate and benefit together. So, through that cooperation, not only could it help in stabilizing threats in space, but hopefully that will also translate down to their host countries here on Earth. In addition to that, sustainability is an absolute must in space. We're going to have to recycle everything. We live in a paradise here on Earth, and we need to stop wasting half of everything that we produce. So hopefully, through learning how to live sustainably in space, that will again translate back to Earth and make us better citizens of the planet.
Thank you very much. And Dr. Hertzfeld, could we have your views?
First of all, Article 1 of the Outer Space Treaty, one of the basic principles of exploring and using space is for the benefit of humankind. We've never adequately defined what we mean by benefits, but I think it's very clear from all the discussion, all the evidence we have, that many aspects of human life are better because of space. We wouldn't be able to do what we're doing today, let alone telemedicine, teleeducation, getting spreading and the benefits of what we've done to all parts of the world. There's a lot yet to be done, of course. I think one of the important questions looking into the future, though, is this debate on commercial space, and that is, are profits good or bad? How do we use commercial space? How do we extend the benefits and build on what we have? I don't think we've adequately answered that question, and we're going to be dealing with it for a long time in the future.
Yeah, thanks. Good points. If we could have Mr. Jean-Jacques Tortora, if we could have your views, please.
I thought he had to leave in between slightly early. Yeah, he did.
Oh, he did. Okay. So, Dr. Farooq, what's your insight on this?
I think the answer is that this has been the case since the original satellite or space program began, especially in the US. And when Sputnik went into Earth orbit in October 1957, the President of the United States of America then was asked the question, how in the hell could the Russians be ahead of us, and what is happening with our people? They told them, Mr. Eisenhower, we have already 3 programs, one in the Army, one in the Navy, and one in the Air Force. He said, yes, that's why we're backward in this. Stop them all and make a civilian agency, which is what's called NACA and then became NASA. And so that civilian agency would be working with all the private sector companies and with all the professors in the university, so we can have an uphill evolution of knowledge in this field throughout the society. And that's how NASA began. So it really is very much happening right now. We're working with all of the agencies and with the academia.
Thank you very much. I think really is this combination of trying to make something that's efficient, that has benefits in other areas as well. And I think that there is a common point in people saying trying to do good things for the Earth. I think that is something that's a common point. I believe the other speakers we have already left, Dr. Simonetta and Dr. Goswami.
I'm here.
Dr. Goswami is still here, sorry. So what are your views, Dr. Goswami?
Thank you, Marcus. So the first question was how the space exploration how will it benefit us? I'm very grateful that I have the GPS, because if I use the GPS and I go from one point address to another, I'm actually reducing global emission because it's much more effective. So already satellite support systems are helping me in tackling with issues like climate change. I think in the next 20 years, given the fact that the former president of India, Abdul Kalam, Wang Shiji, the founder of China's orbital rocket, told us that if humanity is to survive and succeed in a developed way, accessing the resources of the outer system is going to be critical. And I think work like Bill Kemp is doing is going to be vital in that. Now, how does the private industry help us? Let me give you one statistic. So when we had the space launch system, the space shuttle, the cost of taking 1 kilogram to space was $54,000. The United Launch Alliance's Delta 4, charged about $12,000 per kilogram. When we had the launch of the Falcon 9, the cost came down to $1,400 per kilogram. So from $54,000 per kilogram, it came down to $3,000 for the Falcon 9 and $1,400 for the Falcon Heavy. So just look at that estimate, the fall of launch costs with reusability. And with Starship, SpaceX is hoping to bring down the cost per launch per kilogram to $20. I think that is going to be absolutely revolutionary for humanity. People like you and me can dream one day to go to space. I think that's what the private sector has done for us. Thank you.
Thank you. mean, we're certainly running out of time. I have to say that I really enjoyed this. This was certainly even more interesting than I expected. This particular question that was posed, I think it's very relevant. We have to understand the benefits that space can have. And you mentioned satellite navigation. And this is always in my mind, is something that changed everything. Relatively simple, I mean, people hardly think about it, but it made a very big difference. So I thank you all of you. Thank you again for participating. I think this was very good. I thank you for your time. I'm sorry if I pressed you on time sometimes, but I knew that we had a very tight schedule and we had to try to keep on track. I also thank the Trends team for organizing this. And by the way, they asked me to announce that they intend to have an e-lecture entitled Knowledge in the Age of Artificial Intelligence, which is planned to take place on Sunday, the 7th of February. So this coming Sunday at 1900 at 7 p.m. UAE local time. So I think that will also be an interesting one to try to watch. So I thank you again. I thank you, Sumaya, for organizing and for giving me some guidance on this. And I wish you all a very good day. And still, I mean, feels like it's the beginning of the year, but we're already in February. But anyway, a happy new year to anyone.
Thank you, Marcus. Thank you, everybody.
Thank you. Bye-bye. Thank you again.
Thank you.
Have a good day.
Bye. Thank you so much.
Thank you. Bye.